Okay, let's just get quick. In back substitution, if your matrix reduced to this matrix with system equations, this would tell you what x3 is, which could be substituted here, and you could find x2. Now you know x3 and x2. You substitute those here, and you find x1 very easily. Okay. Now then they give you, your book has the equation that looks like this. What in the world are you going to do with that?
Well, x2 equals 0, so x1 and x3 are inverse of each other.
Conclusion, x1 plus x3 equals 0. Okay? So x1 equals negative x3. Well, your book says, okay, whichever one of these you solve for, whichever one's on the left, is solved in terms of the one that's on the right. So now we could say, okay, well, the one on the right is what we're going to call a free variable. You can take any number, take any value, and that determines the value of this one. And we've already determined the value of this one, right? So you can say, okay, x1 equals negative t, x2 equals 0, x3 equals t is a solution for any value of t. And that's a parametric, it's this set of parametric equations for the solution. Okay? Make sense? Very simple. You've actually done something very similar. Like with eigenvalues, when you find that every solution is a multiple of this one vector, and that one vector is not unique. You might just choose to let this equal 1 and this equals whatever it is, but the ratio of the two numbers is determined, right? So you kind of remember something like that. It's very similar. You could write that as t, the eigenvectors are vectors of the form t times 1, 4. Okay? Now we use C instead of T. There's total similarity. Make sense? Okay. So that's the idea of a free variable. And when we have a free variable, we'll just choose a letter for it. T's a typical one. Okay, because kind of think of this as points moving in time. As time goes from 0 to infinity, or negative infinity, or infinity, or whatever, this is the path you take. Okay, these are the vectors you get. Okay? If you have two free variables, which you could, like if your equation was just this, then you could say x3 equals negative x1 minus x2. So u equals x1, v equals x2, and x3 equals u plus negative u minus v. Okay? That's the idea. So kind of think about that notation, or that terminology, because you'll see it.